Next, solution of differential equations by separating the variables. Now, if the differential equation is of the form dy dx is equal to f of x over f of y. Now, what I did see was if you have a dy dx and a x inside the equation and a y, right? This represents somewhat of a function of x being in the equation, and this represents a function of y being in the equation, right? Having dy dx given as a subject of the formula, and a y, the dy dx being a function of y and a function of x, meaning you're seeing dy dx is equal to something with a y and something with an x. We said if you're seeing dy dx, y's, and x's, you solve by separating the variables. Again, that is what I actually said in the class, but I did not read these official notes for you. But you can use this as official if you want. Alright, it says then after some manipulation, the solution can be found by direct integration, which we also did in class, and we did not do this very example, but this is pretty close to it. So how would I know this is separating the variables? Well, because I see the y dx, I see an x there, and I see a y there. So I put the y's on one side, x is on the next side, and you just integrate, and this is our answer. Or I think this was the example. And this is our answer, and it is as simple as that. Then we went on to the homogeneous equations, or homogeneous equations, which we solve by substituting y is equal to vx. So of course you might not know it's a homogeneous equation from the beginning or know what method to use. So first of all, you see an x and a y, you know for sure you have to separate the variables, but then you can't separate this. Next step, try to see if the powers of every term is the same. This has a power of 1, this has a power of 1, and this has a power of 1. All the variables has the same power for every term. So it is a homogeneous equation. So for homogeneous equations, what we do is replace y with vx, put it right there, and we divide the entire side of this fraction by the highest power of x, which in this case would be x. So we would have x over x plus 3 multiplied by y over x divided by 2 multiplied by x over x. Alright, which would give me alright, they kind of skipped the step. Alright, let's continue speaking. So I said here we have vx, we would have vx here, and here we have x over x plus 3 multiplied by y over x divided by 2x over x. Alright, so if we differentiate vx, which should be here, right, with respect to x, using the product rule, we would get v plus x dv dx. And if we divide every term in this fraction by x, we would get 1 plus 3 y over x over divided by 2 times 1 x, which is x over x. And then we would replace every x over y term with v. So this would become this. Oh no, they didn't actually skip the step. If y is equal to vx, they have v of x here, just showing that v of itself is a function of x, but we would just use vx. Don't worry with this v, don't worry with the x in the bracket. You don't have to put this x in the bracket all the time. Alright, so if y is equal to vx, then dy dx is equal to v plus x dv dx, and this is simply equal to that. What we do, divide everything by an x and replace y over x with v. So we simply have this. Alright, so what we are left with is this, which is just v plus x dv dx is equal to 1 plus 3v over 2. So what we do, we throw over the v, right, and we will get 1 plus 3v divided by 2 minus v is equal to x dv dx. And of course, you do the same thing that we did earlier today. Make it one fraction, and you will have this, and this can now be solved using the separation of variables method. Right? So of course, when you are at this stage, what we would simply do is put the terms with the v, this whole block of terms, or just put this over there and put the dx here and the x there. This example is in the book, and that is all. But this is all we covered on the 30th of January. Fairly straightforward. On Friday, we will be continuing on the same topic of differential equations. We'll be going on to the use of integrating factor, which we do for linear equations, and well, that is our example. And finally, Bernoulli's equation, and we will come to the end of first order differential equations. That is not including applications, but learning how to apply yourself in solving first order differential equations. When we get this done really good, then we can move on to applications with, for instance, the tank with the water, and you want to raise the salt concentration and etc. and whatever. Alright, now by way of announcement, on Friday we have our first test. Now the test on Friday, as I said, 7 questions will be given. The 7 questions will be chosen from the examples under the topics integrating separating the variables and homogeneous equations. That's the examples, this test exercises, and the further problems. Of those 7 questions are going to come, you are only going to have 5 minutes to do the 7 questions. Now, how we accommodate for this? You'll be placed, or you'll place yourselves in groups of 7. All right. So you identify a group, and you have you sit together, and each person would choose their question. They do it for the 5 minutes. We staple everything together, and you hand it up, and the entire group would get what the relevant marks. Right. So please hand up your groups this week before Friday will be better. Right. So that is it.